Hey guys, so today we're going to be learning Chapter 13, Section 8, which is Reciprocal Trigonometric Functions. And the objectives for this section are to evaluate reciprocal trigonometric functions, as well as to graph reciprocal trigonometric functions. And thinking about this equation, if you're trying to solve for ax equals b, and we're trying to solve for x, the way that we would get rid of a is either by dividing by a or multiplying by its reciprocal, which is the same thing. So multiplying by 1 over a on both sides. When we multiply 1 over a on both sides, these cancel out, and we're left with x equals b over a. If a is a trigonometric expression, you need to use the reciprocal as well. An essential understanding for this section. Cosine, sine, and tangent all have reciprocals. Cosine and secant are reciprocals, as are sine and cosecant. Tangent and cotangent are also reciprocals, so each trigonometric function has a reciprocal. Now, our key concept for cosecant, secant, and cotangent functions. The cosecant is represented by CSC, secant is represented by SEC, and cotangent is represented by COT. Functions are defined using reciprocals. Their domains do not include the real numbers theta that make the denominator 0. So this is very important. Your domain is going to change now because we're talking about the reciprocal. Cosecant is going to be undefined wherever sine is equal to 0, because then that makes your denominator 0. So that's a very important thing to remember. So we have our cosecant is represented by 1 over sine of theta, secant is represented as 1 over cosine of theta, and cotangent is represented as 1 over tangent of theta. And a little helpful hint to remember what trig functions go with the reciprocals. We have sine of theta, cosine of theta, and tangent of theta. For the reciprocals, what matches up with sine is cosecant of theta, cosine matches up with secant of theta, and tangent matches up with cotangent of theta. Tangent's pretty easy to remember because cotangent has the word in it, so tangent and cotangent match up as reciprocals. Sine and cosine, it gets a little tricky because these letters are opposite, but remember, a number and its reciprocal are not the same. So for example, 2, the reciprocal of 2 is 1/2. 2 and 1/2 are not the same. They're different numbers. So with your reciprocals, the letters have to be different. So it's not the same value. They're different. Sine of theta reciprocal is cosecant. Cosine of theta is secant. So a little helpful trick to remember, your letters have to be different when you're talking about the reciprocal. Now, we can use the unit circle to evaluate the reciprocal trigonometric functions directly. Suppose the terminal side of an angle theta in standard position intersects the unit circle at point xy. Then cosecant of theta would be represented by 1 over y, because cosecant is 1 over sine of theta, and sine is represented by our y value. Secant of theta is represented by 1 over x, because secant is 1 over cosine of theta. And cotangent of theta is represented by 1 over tangent of theta. And we learned in the last lesson that tangent is represented by 1 over y over x. And if we flip this, it becomes x over y. So cotangent of theta is represented by our x value of the point over the y value. You can use what you know about the unit circle to find the exact values for reciprocal trigonometric functions. In our first example, what is the exact value of cosecant pi over 6? So if we think about pi over 6 in our unit circle, pi over 6 is going to be in the first quadrant, and because the denominator is 6, that means this is a 30-degree reference angle. If it's a 30-degree reference angle, then our points are going to be radical 3 over 2, comma 1/2. And it's very important to figure out which quadrant you land in, this theta lands in, to figure out if your x values or your y values are going to be negative. Now we're talking about cosecant. So we have cosecant of pi over 6, that's equal to, remember, your letters, the reciprocal letters, have to be different. So cosecant of pi over 6 is equal to 1 over the sine of pi over 6. So to figure out the sine of pi over 6, we're going to do 1 over. Sine is represented by our y values. So the y value in this is 1/2. So to figure out cosecant of pi over 6, we're going to do 1 over 1/2. This is a complex fraction, so if we write it out, this is going to become 1 divided by 1/2. And we can multiply by the reciprocal, so 1 times 2 equals 2. So the cosecant of pi over 6, the exact value is 2. And you can figure this out without doing all of this work also. For cosecant of pi over 6, you know the letters have to be different, so we're talking about the sign. So you can just look at this y value of the point, it's 1/2. Because we're talking about the reciprocal, we know that our reciprocal is 2 over 1, so you can just take your y value and flip it to get the exact value of your cosecant. Let's look at another example. So we have what is the exact value of cotangent -5 pi over 6. So again, the first step is figuring out what quadrant we're in on our unit circle. So we have our angle of -5 pi over 6. To make this a little bit easier, we can figure out a coterminal angle by adding 2 pi. I'm going to add 12 pi over 6 just so that I have a common denominator, and we're left with 7 pi over 6 as a positive coterminal angle. For our unit circle, if we label, we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So the angle 7 pi over 6 is going to be in our third quadrant, where our x values and our y values are both negative. And because the denominator is 6, that means this is a 30-degree reference angle. And remember, if we draw out this angle, -5 pi over 6, we're going to be moving in the clockwise direction because it is negative. So we have a reference angle of 30 degrees. That means that our coordinates for this point on the unit circle are going to be radical 3 over 2, comma 1/2. But because we're in the third quadrant, both of these values are negative. So now we have to figure out the cotangent using this corresponding point. So we know that cotangent of theta is equal to x over y because it is the reciprocal of tangent. So cotangent of -5 pi over 6 is going to be equal to negative radical 3 over 2 divided by -1/2. So we have a complex fraction. In order to solve, we can multiply by the reciprocal. So we'll have negative radical 3 over 2 times -2 over 1. So rather than dividing by -1/2, we're going to multiply by -2. And when we multiply, our negatives cancel out and our 2's cancel out. So we're left with radical 3. So the cotangent of -5 pi over 6 is equal to radical 3. Let's look at a few more examples. So what are the exact values of? Our first example, we have the cosecant of pi over 3. Pi over 3 is in the first quadrant, and if our denominator is 3, that means we have a reference angle of 60 degrees, which makes our corresponding point on the unit circle 1/2, comma, radical 3 over 2. Because we're taking the cosecant, that is the reciprocal of sine. So cosecant of pi over 3 is the same as 1 over sine of pi over 3. When we're talking about sine, that means we're using our y value of the corresponding point. So it is going to be cosecant of pi over 3 is going to be equal to the reciprocal. So it's 2 over radical 3. But here we have an improper fraction because the radical is in our denominator. So to solve, we're going to multiply by radical 3 over radical 3, and we're left with 2 radical 3 over 3 as our final simplified answer. For B, we have the secant of 3 pi. So we have 3 pi. Let's figure out a coterminal angle. So to figure out our coterminal angle, we're going to subtract 2 pi, which gives us pi. So we know for pi, we are on the negative x-axis, which makes our corresponding point -1, 0. For secant, that means we're doing 1 over cosine of 3 pi. So for cosine, we are using our x value, which would make it 1 over -1, which simplifies to -1. So the secant of 3 pi is equal to -1, and the cotangent of -5 pi over 4. For cotangent, that means we're doing x over y, because it is the reciprocal of tangent. -5 pi over 4, let's figure out a positive coterminal angle. So we're going to add 2 pi. In this case, I'm adding 8 pi over 4 so that we have a common denominator, and we're left with 3 pi over 4. 3 pi over 4 is in the second quadrant. And because our denominator is 4, that means it's a 45-degree angle, so our corresponding point is going to be radical 2 over 2, comma, radical 2 over 2. But because we're in the second quadrant, that makes our x value negative. So now to solve for the cotangent of -5 pi over 4, we're going to do x divided by y, so negative radical 2 over 2 divided by radical 2 over 2. To solve, we're going to multiply by the reciprocal, so negative radical 2 over 2 times 2 over radical 2. Everything cancels out, radical 2 and radical 2, 2 and 2, and we are left with -1 as our final answer. So the cotangent of -5 pi over 4 is equal to -1. So this is how we use the unit circle to figure out our exact values. It's very important first to figure out where you are on the unit circle and what quadrant your point lies in, so you can figure out if your x or your y values have to be negative. Then you determine your corresponding points and use that to solve using the reciprocal function. So let's try one more example. So given theta equals -5 pi over 3, determine the following: the quadrant, the corresponding points, and from the corresponding points we will be able to determine the secant, cotangent, and sine of theta. So first let's think about this on our unit circle. So I'm going to start by labeling the axes of our unit circle. And we have a theta of -5 pi over 3. -5 pi over 3 is difficult to work with, so we're going to find a positive coterminal angle by adding 2 pi. So I'm going to add 6 pi over 3, so we have a common denominator, and we're left with pi over 3 as our reference angle. Pi over 3 lands in quadrant 1. And because the denominator is 0, we know that we have a 60-degree reference angle, which makes our corresponding points 1/2 and radical 3 over 2. Everything in quadrant 1 is positive, so our x and our y values stay positive. Now, to determine the secant, cotangent, and sine. So for secant of theta, we are using secant, the reciprocal function is 1 over cosine of theta. Remember, your letters have to be different, which is equal to 1 over x. The x value of our corresponding point is 1/2, so if we flip that, our secant of theta is going to be 2. For cotangent of theta, cotangent is equal to 1 over tangent of theta, or x over y. So if we solve for x over y, or x divided by y, we have 1/2 divided by radical 3 over 2. To solve, we're going to multiply by the reciprocal, so 1/2 times 2 over radical 3. When we multiply, our 2's cancel out, and we're left with 1 over radical 3. However, this is an improper fraction. We cannot have a radical in the denominator, so we have to rationalize. So 1 over radical 3, we rationalize by multiplying radical 3 over radical 3, and we're left with radical 3 over 3 as our final answer. So the exact value for cotangent of negative 5 pi over 3 is radical 3 over 3. And for sine of theta, we're not even using the reciprocal. Sine is just represented by our y value, so that's going to be radical 3 over 2. And here are all the exact values based off of that corresponding point. So it's extremely important first that you draw out your unit circle, figure out which quadrant your angle lands in, then from there determine your reference angle, corresponding points, and then you can use your reciprocal functions or just your regular trigonometric functions to figure out the exact values. You are also able to graph reciprocal trigonometric functions, and the graphs of the reciprocal trigonometric functions, well, that's a tongue twister. The graphs of the reciprocal trigonometric functions have asymptotes where the functions are undefined. So your reciprocal functions are always going to have your asymptotes because, for example, cosecant of theta is equal to 1 over sine of theta. So wherever our sine value is equal to 0, that's going to make cosecant undefined because we have 0 in our denominator. So what are the graphs of y equals sine of theta and y equals cosecant of theta? First, let's look at the graph of y equals sine of theta. We've done this one before. For sine, our pattern is 0, max, 0, min, 0. And we can continue that pattern to fill out the rest of our function. The period is 2 pi, so we go through one cycle from 0 to 2 pi. Now, if we're graphing cosecant, we know anywhere where a sine function is equal to 0, cosecant is undefined. So those points are going to give us vertical asymptotes for cosecant. Anywhere where your sine function equals 0. And just to make it clear, in red we're graphing y equals sine of theta. And in blue, we're graphing y equals cosecant of theta. So for the next part, to actually graph y equals cosecant of theta, we have to think about the information that we're given and our unit circle. So remember, for your unit circle, we can use this acronym, all students take calculus, to determine which functions are positive in which quadrant. So first quadrant, all trig functions are positive. Second quadrant, sine functions are positive. Third quadrant, tangent functions are positive. And fourth quadrant, cosine functions are positive. So now, in between our asymptotes, at pi over 2, we're going to use this maximum point on our sine function to use as the base of our cosecant graph. So thinking about that point, we're between 0 and pi. On the unit circle, between 0 and pi means we're in quadrants 1 and 2. In quadrants 1 and 2, sine functions are positive. So for the cosecant graph, between 0 and pi, from this point, we're going to be moving in a positive direction. So your graph between 0 and pi should look like that. And your graph should always be approaching your asymptotes. For 3 pi over 2, now we're between pi and 2 pi. Between pi and 2 pi on our unit circle, sine functions are negative, so we're going to be moving in this negative direction. And you can double check. So we know between 0 and 2 pi, all sine functions are negative. So if you accidentally graph the wrong way, you can see from this point, if we move in a positive direction, part of our graph is negative, but then we move into the positive, so that's incorrect. All values have to be negative on this graph. So that's one way to check. So if we move in the other direction at negative pi over 2, now we're between 0 and negative pi. From 0 to negative pi on our unit circle, sine is negative. And if we do 5 pi over 2, from 2 pi to 3 pi, we're positive again. So our graph would be in the positive direction. So the graph of cosecant looks like that in blue. And you can continue this pattern on throughout your function. It's a periodic function to keep graphing your cosecant of theta. And the period of cosecant of theta is the same as sine of theta, which is 2 pi. Let's look at what are the graphs of y equals cosine theta and y equals secant of theta. So this is very similar to the last problem that we just looked at. In red, again, I have sine of theta graphed. For sine of theta, our pattern is 1, 0, negative 1, 0, 1. And the same thing applies. Where cosine is equal to 0, that's where we're going to have a vertical asymptote for secant. So you can draw your vertical asymptotes where cosine is equal to 0. That's what's going to make secant undefined. So here are our vertical asymptotes. Again, we can think about our unit circle and our acronym. All students take calculus. Now we're talking about cosine. So cosine is only positive in our first and our fourth quadrants. And before we start graphing our secant, notice from negative pi over 2, negative pi over 2 to 3 pi over 2, that's still one full cycle, and the period is still 2 pi. So now to graph our secant, we start at this point up here. Now we're between negative pi over 2 and pi over 2. That is the first and the fourth quadrants. So our secant is going to be positive, so our branches will be going in the positive direction. Let me just get it going through that point. From pi over 2 to 3 pi over 2, cosine is negative, so it'll be going in the negative direction. From 3 pi over 2 to 5 pi over 2, we're positive, so our branches will be going in the positive direction and always approaching our asymptotes. From negative 3 pi over 2 to negative pi over 2, cosine is negative, so we'll be going in the negative direction, and so on. So this is just an idea of how you can graph your reciprocal trig functions. And the last thing that we're going to go over in this section, everyone's favorite, a word problem. So you can use reciprocal trigonometric functions to solve real-world problems. So a restaurant is near the top of a tower. A diner looks down at an object that makes an angle of theta with the tower. How far away is the object sighted at an angle of 30 degrees? So normally for your trig functions, reciprocal functions, you will be given a theta in radians, but sometimes, very rarely, it could be in degrees. So we're going to talk about that with this problem. So before I go to the next slide, think about what this is going to look like. A diner near the top of a tower is looking down at an object on the ground that makes an angle with theta. So we have to figure out the distance from the diner to the object if the angle is 30 degrees. So here's what this diagram could look like. We have a tower with a restaurant at the top of the tower and a diner viewing an object that is on the ground from the tower. So the distance from our diner to the object on the ground is represented as d. We know that the height of the tower is 601 feet, and theta, the angle that is formed by the tower and the view going down, is 30 degrees. So we have to use this information to try to set up an equation. So we're going to use what we know to set up an equation. Notice that we have formed a right triangle, and we have two sides. The two sides that we're looking at of our right triangle are the hypotenuse and the adjacent side. We know we can use one of our trig functions to set up an equation to solve using the adjacent side and the hypotenuse. So what can we use for adjacent and hypotenuse? Think about our acronyms. So, TOA. Using adjacent and hypotenuse is going to be cosine. So our cosine of theta is going to be equal to, the adjacent side is the height, so 601 over d. But in this word problem, we're trying to solve for the distance. So we're solving for d. So to set up an equation that represents this word problem, we need to isolate d. So to get d out of this fraction, we're going to multiply both sides of our equation by d. When we do that, we get d times the cosine of theta equals 601. Now we almost have d by itself, but we have to divide both sides by cosine of theta. Now we have isolated our variable which we're trying to solve for. So d is going to be equal to 601 times 1 over cosine of theta. But be careful, in this section we learned that the reciprocal of cosine is secant, so we can rewrite this equation as d equals 601 secant of theta. So that's our equation. Now to solve, first I'm going to get rid of this down here. To solve, we're talking about a theta of 30 degrees. And when we have a reference angle of 30 degrees, we know that our corresponding point on the unit circle is radical 3 over 2, comma 1/2. And in this case, note, we're not worried about what quadrant we're landing in because we're talking about a real world problem, and units, we know our answer has to be positive. So both your x and your y values are positive. So now to solve for the distance, we're going to do d equals 601 secant of 30 degrees. So now when we solve, we have 601 times secant of 30 degrees. Secant is the reciprocal of cosine. So with cosine, we're talking about our x values. And if it's the reciprocal, we're just flipping our fraction. So it's going to be 601 times 2 over radical 3. When we multiply, 601 times 2 gives us 1,202 over radical 3. We're not done though. We have to rationalize. We can't stop with a radical in our denominator. So to rationalize, we're going to multiply by radical 3 over radical 3. And our final answer is going to be 1,202 radical 3 over 3. But don't forget, we're given units. Our distance is in feet. So the distance from our diner to the object that they are looking at on the ground is 1,202 radical 3 over 3 feet. And that's it for this section. Your homework is posted to Google Classroom. On Friday, there's going to be an exit ticket on sections 6 and 8, and then we're going to move on to chapter 14 next week. If you have any questions, please feel free to email me. Good luck.